polygon. Can you give me an example of a polygon?
I think poly means five, so polygon is the five-sided shape.
Penta would mean 5. So I think you're thinking of pentagon.
Poly means multiple.
Okay, multiple what?
Multiple sides or something. I was thinking, poly means almost
Okay, so multiple sides. So like if I said draw an example of a polygon, what is a shape that comes to mind? A square, a triangle. Okay, Clark's example that he was thinking of, a pentagon. Okay, those are all examples of polygons. So the official definition of a polygon is a closed figure formed by a finite number of sides. So Harvey said many sides, okay, but we can't have an infinite number of sides. Multiple, many. Sorry. Oh, that says finite. So like not infinite. Sorry, I didn't write it very well.
It just has sides, but it's not infinite.
Yes. Okay. And we're gonna go through the names of a bunch of polygons based on how many sides they have. You good over there? Okay, here are 2 examples of polygons. Okay, now you might not have thought of something like this when you are picturing a polygon, but technically this is a closed figure, right? That's all the sides have endpoints that meet up, formed by a finite number of sides. Okay, technically this is a polygon. Okay, now what I want you to understand, where the sides meet, where we have the corners, these are what we call vertices, 1 vertex. Okay, we have 4 vertex points on each of these. Okay, sure. And then I don't think that I need to point this out, but I will. These are sides. The red lines are sides. What kind of quadrilaterals did I, oh my gosh. We were just talking about this at dinner. My kids were asking us, because my husband and I, every once in a while we do this. We get so excited about a question. We put the answer in the question. I was gonna ask you, what kind of polygons did I draw?
Quadrilateral.
I drew quadrilaterals. Yes, wow. Why are they quadrilaterals? Because they have 4 sides. Okay, so we're gonna make a little chart, really small, about all the different types of polygons that we have. Okay, so based on the number of sides and then the name of the polygon. Okay, guys, we cannot have a 2-sided polygon. That's not gonna work. Yes.
Is the circle technically a polygon because it has one giant side?
You have to have multiple sides.
It says a closed, wait, it's not a closed figure though.
How is it not a closed figure?
Circle, oh, I was about to say, I thought you were talking about just one.
Yeah, a polygon with one side is kind of what you're thinking. Yes, I mean, I see where your logic is,
Wait, doesn't.
but for polygons, we need to have like, our sides have to be straight. So I'm gonna say no, a circle is not a polygon.
It's like you have to have a vertex. Like, if it's a
Yes, we
circle,
need
then-
sides and vertex points,
Okay.
which a circle would not
We need
have.
the vertex.
I like where your head's at though, Presley. All right, so 3 sides is a
Triangle.
and 4 sides.
Rectangle.
That is an example of one, but not all. No
Aren't all squares
Quadrilateral.
rectangles though?
quadrilaterals. All squares are rectangles. And you know what? We're gonna have an entire chapter second semester on quadrilaterals. An entire chapter. You love squares? Five sides. Yep.
Nailed it.
Okay, that's why that's why we have pentas, because we have 5 rotations of your electives.
I don't
Well, I
want to
do.
say that.
Okay,
Even though I know the next one, I don't want to say.
Sure,
it.
Brandon.
Sure.
Okay.
You really realize that.
6 sides.
Hexagon.
Octagon.
Hexagon.
Octopus.
Hexagon.
Squid. Octopuses have 6 legs.
Yes.
I got it.
Octopuses have 8 legs.
Well, like, aren't there some with 6 legs?
And if they lose one,
Well,
Like
some
Hank?
of them- There's some types of octopuses that have 6 legs.
okay, you look that up for me and you show me.
I've never heard of that.
That's a squid, my guy.
All right. 7. It is not sept, but how about with an H? Heptagon. And you all
I know the
know,
next one.
what is it, Sam?
Octagon.
What? No, let's not joke like that, okay? He said nothing.
Brandon just told me.
I'll give you a Jolly Rancher if you know what an inside polygon
A what?
Isn't it not enough?
it is.
What? Yo, it's an octagon.
I thought you
He
said
blurted.
inside it.
He blurted.
I didn't know what you meant.
Yeah, he blurted it. That's not fair. I had a chance.
I said 9-sided.
He blurted it.
I
I
had a
had a
chance.
chance.
Octagon. He blurted.
He blurted. I didn't have a chance to answer.
Yeah.
Sam, do you know what a 10-sided?
Pentagon. Hexagon. Septagon.
Decagon.
Wait, does the pentagon have 5 sides?
Yes.
Yes, Ben.
Up there.
No, like the pentagon.
Yes, that's why it's called the Pentagon.
No, where do the doors are?
What?
They're on one of the 5 sides.
Wait, what? Wait, it goes.
Okay, and the last one, 12.
Decagon?
Yes. Decagon.
That sounds like a transformer.
I know.
That's the one that I remember.
And then if we have a number of sides that is not 3, 4, 5, 6, 7, 8, 9, 10, or 12, we call it an n-gon. So like an 11 gone or a,
Why is it nothing but
11 is
popcorn?
gone.
I don't know. I don't know why 11 isn't gonna be special.
It's an odd number.
Side.
11 is just nice and lonely.
Maybe
I don't know.
11 is like no knowledge.
No, that's 12.
Okay, all right. Now, we need to understand the difference between convex and concave. I have an example of each of them up here because it caves in.
Oh my god, I do this one.
Okay, so this is a convex and this is a concave. Okay. So for a convex, you can connect two vertices and not go outside of the shape. Okay, so if I connect any two vertices up here, I'm gonna stay inside of my shape. Do you see what I'm saying?
Oh, yeah.
Yes. Vertices is the plural for vertex. Okay. Now, if I come to this one and I can connect these fine, but when I connect these two vertex points, my line is outside of the shape, and that's how we know that it is not convex, but concave. Now, when we name our polygons, we are going to do so by listing the letters in consecutive order, okay? So here I have a pentagon, and I'm gonna name it A, B, C, D, E, because there are 5 vertex. Well, there's 5 vertex points. Okay, so I go A, B, C, D, E. Okay. There's 26 letters in the alphabet.
There are 28 days in the week.
That's cat.
Okay. So notice how our side is a line segment. Okay. Our vertex points are going to be points. And then we're going to use all of the vertices to name the polygon. Okay. Could you please turn in your folders to whatever page this is? I'm gonna guess 8.
It's
Dang
10.
it. Page 10.
We've already done it.
Fair enough. So on page 10, I would like you and your elbow partner to together classify this green and this red shape by what kind of polygon it is and whether it's a convex or a concave. You have 30 seconds.
First one's concave, the second one's convex. What if I take the number of sides? 1, 2, 3, 4. Which 4?
Yo, I'm here.
5 sides.
All right. Benjamin, what is the green one?
That is a concave pentagon. Jolly Rancher.
All right, Nora, what's the red one?
Oh wait, concave, octagon. Oh, convex, yeah.
Okay, and why is it convex as opposed to concave, Nora? Why did we change that?
Because the vertices do not go outside the shape, or it's not like this.
Okay, so it doesn't cave in,
Yeah.
right?
I wrote that, but I said the wrong thing.
Fair enough, fair enough. They're very similar words, right? Okay, so I am going to ask you to find some perimeter and area. So here are a couple of reminders for when we're finding perimeter and area. Perimeter means we just add up all the side lengths, okay? Area, 1/2 length times width, side times side, length times width. Are you okay with that?
Yep.
Okay, so here are going to be a couple examples we're going to do. We'll see how long we have until the bell rings. The perimeter of ABC. Okay, we can do this. How long is side AC?
7,
6. Yes, 6.
Yeah,
7.
It's 6.
1, 2, 3, 4, 5, 6.
7.
Where do you
Please.
Count it.
Never mind, never mind.
Okay,
It had a delay.
it had a delay. What about CB? 5. All right, how are we going to find AB? Okay, you can use the Pythagorean theorem or you can use distance formula. I don't care. Just because we came off of the quiz with distance formula, it's just a version of Pythagorean theorem. I just want to make sure that we have the distance formula under control. So we're finding the distance between A and B. So I'm going to take 3 minus -2 squared, and then I'm going to take -3 minus 3 squared. Okay, x minus x squared plus y minus y squared. So it looks like we have 5 squared plus 6 squared. Well, -6 squared. So what, we have the square root of 61? Okay. So our perimeter is 6 plus 5 plus a square root of 61. Okay, now we could plunge the square root of 61 into our calculator and get a decimal, okay? And that's fine. We won't worry about that right now, but this is what our perimeter would be.
7.8.
Oh, 7.8. So our perimeter would be approximately 18.8. Okay, now in that second example that I have on that page, I want us to find the area. Oh, it's a triangle, right? The area of a triangle is 1/2 base times height. So, how long is the height of this triangle?
6.
Do you agree with Clark?
Yes.
How about the base?
8.
8?
Yeah.
So area is 1/2 base times height. I'm sorry. Is this too easy?